Hi folks, welcome to day 28. Today we are going to be going through section 8.5, which is all on graphing y equals a times x minus p times x minus q. So now that we know how to graph in standard form, y equals ax squared plus bx plus c, and now we also know how to graph in vertex form, y equals a times x minus h quantity squared plus k, now we're going to be learning how to graph in intercept form. So y equals a times x minus p times x minus q is called intercept form because we have x-intercepts at p comma 0 and q comma 0. Again, I'm going to make that really big point that here we have a positive p and a positive q, when up here we have the negatives, okay? So remember to flip those signs. So if you have x plus 4 in there, then your p would be negative 4. Or x plus 2, your q would be negative 2, all right? So your x-intercepts are always at p and q. I'm going to tell you, it doesn't matter which one you pick as p and which one you pick as q, all right? There's no difference in them. They mean exactly the same thing. All they mean is they're an x-intercept. The only reason why we have different letters that represent them is because they are almost always different numbers, all right? So in order to graph in intercept form, you have a few points, all right? You're going to have to, in intercept form, you're going to have to be graphing your x-intercepts, but you're also going to have to graph your vertex, right? So let's go ahead and talk about that vertex first. So your vertex in standard form was negative b over 2a, and then we had to plug in that value back into that original equation, right? Well, that same exact concept is going to be applied here, except for our vertex, the x value of the vertex is at p plus q over 2, or halfway between. All right, so your vertex is always halfway between your two x-intercepts. All right, so that's the x value of the vertex, and then you plug that back in. All right, just like what we did last week, we plugged in the negative b over 2a, all right? We plug that into the equation y equals ax squared plus bx plus c. Similarly here, we're going to take this p plus q over 2, find out whatever number that is, all right, and then plug that back into our equation y equals a times x minus p times x minus q. So I told you that you had 3 steps in order to graph. Step 1, graph your x-intercepts. I'm going to be abbreviating intercepts as ints, I-N-T-S, because intercept is a long word. All right, so you're going to graph your x-intercepts as your first step. Because remember, they're given to you in your function, right? So if we had like y equals 2 times x minus 4 times x plus 2, right? Our first step would be to graph our x-intercepts of positive 4 and negative 2. All right, those are our x-intercepts because we have to flip the sign. All right, so first step, graph the x-intercepts. Second step, find and graph the vertex. Remember that vertex is p plus q over 2, and then plug that back into your function to find out what that gives out as your y value. Okay? Third step, connect the 3 dots with a U. There are still some people that, like, if you have 3 dots, you're like, hey, I have 3 dots, I'm going to connect them with a V. It's not a V, okay? It's a U. It has to be a U because quadratics are always U's. That's what they always look like. They're always parabolas, they're always symmetric. But the bigger reason why you don't want to graph it as a V like that is because that is an absolute value function, which you'll work a lot with in advanced algebra. So it's really important you get in the practice now of not connecting your 3 dots with a V, but with a U. All right, so 3 steps to graph in intercept form. First, identify and graph your x-intercepts. Second, find and graph your vertex. 3, connect them with the dots. All right, in my opinion, I honestly believe that the intercept form is the easiest because finding the vertex is super easy. That's okay if you don't believe me because I'm going to walk through an example. So if we have y equals negative times x plus 1 times x minus 5. All right, your first step in any of these problems should always be to write out the formula underneath. I'm going to strongly recommend that because then you can see the differences between the two, all right? And you can also really easily identify what's what. So I can see my A is this negative sign, but a negative sign isn't a number, okay? A is negative 1, all right? Remember, there's an implied 1. Here I have my P is, so I have an x plus 1, all right? But I should have an x minus P. So the only way in order to get a plus 1 is if P is negative 1, all right? Because that's x minus P, but we're replacing P with a negative 1. So we have x minus the negative 1. That gets us an x plus 1, all right? That's why we have to flip the sign. So P is negative 1, and Q, so I have x minus 5 and x minus Q, so Q is positive 5, all right? So A is negative 1, P is negative 1, and Q is positive 5. All right. We've identified our x-intercepts, so now we're going to find our vertex. So our vertex, we always start with P plus Q over 2. Well, P is negative 1, so I have negative 1, plus Q, which is 5, over 2. And I have negative 1 plus 5, which is positive 4, over 2. It's a really weird looking 4, but it is a 4, okay? Believe me. So I have 4 over 2, and that's just 2, all right? So our x value of the vertex is 2, all right? That also means that our axis of symmetry is at x equals 2. Remember, the axis of symmetry is always, always, always at the x value of the vertex. All right, so we have the x value of the vertex, but that's not enough. We need that y value too. So, since I know that my original equation was negative x plus 1 times x minus 5, well, my new x is 2, all right? So when we're plugging that in, I have negative, instead of x plus 1, I have 2 plus 1. So I have negative 2 plus 1 times 2 minus 5. All right, well, 2 plus 1 is 3, and 2 minus 5 is negative 3, all right? So I have negative times 3 times negative 3. So negative times 3, well, that's just negative 3, all right, times negative 3. Negative 3 times negative 3 is a positive 9. So your y value is 9. Your x value is 2, your y value is 9, so you have a vertex at 2, 9. But remember, you had x-intercepts. You had x-intercepts at negative 1, 0, and at 5, 0. So now we have 1, 2, 3 points, and those are going to be the 3 points we graph. All right? All right, so we have our x-intercepts at negative 1 and at 5. So I'm going to plot those first in purple. So I have negative 1, 0. They're an x-intercept. That means they intercept the x-axis. All right? That means they're on the x-axis. If I see your x-intercept up here in the sky, I'm going to be able to tell that you didn't watch this video and that you didn't pay attention if you did watch the video. All right? The x-intercepts are always on the x-axis. So I have my x-intercepts at -1 and at +5. So I put them at x equals -1 and x equals +5. Then I have my vertex at 2, 9. So I go to the right 2 and up 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I have my 3 points and I connect them with a U. All right. So you can see when I'm connecting with a U, I purposely go and actually make it like U-ular, right? Like it's nice and U-shaped. All right. But because we always ask for the axis of symmetry in that vertex, I'm going to say, oh, look, there's my vertex. And then I'm going to put the axis of symmetry down that x value of the vertex. All right? So that's all you have to do in order to graph an intercept form. Okay? You start by graphing the x-intercepts. You find and graph the vertex. Connect those 3 dots with a U. Okay? The biggest thing that I'm going to recommend for you here is that when you're going through the part where you're going to mess up the most, the part that's going to make it so that way your graph doesn't look right, is this portion right here. The plugging in of this, of the plugging in of the x value of the vertex. That's where I see the most errors. And that's because some of you still aren't following PEMDAS. All right? So make sure you're actually following PEMDAS. I know some of you are like, oh my gosh, Ms. Kessler, stop talking about PEMDAS. I'm so done. But really, make sure you're following PEMDAS because that's where you're going to make mistakes. Keep in mind, too, that if your graph doesn't have a U in it, right? If you have a graph that looks like, I've seen some where you have like a dot down here, a dot up here, and then a dot somewhere on the way over there, and you're like, yep, I'm just going to connect them with an arrow like that and like a corner. All right, remember that if your graph doesn't make a U shape, you probably didn't do it right, okay? So if you are going through and you're trying out these problems, if you're not getting a nice U shape, that's when you should be emailing me and saying, hey, Miss Kessler, I'm stuck because I'm not getting the U shape you want, all right? If you don't get the U shape, please, please, please email me. There have been a couple of you that have emailed me with every single assignment because you just want to make sure that you're getting stuff and doing it properly. That's totally okay. Feel free to email me. Normally I would talk to you in person, but we're not in person right now. We're over the internet, and I know that that's challenging. I know that this is hard, and I have never had to do high school the way that you guys have, and the fact that you're powering through this is amazing. Okay, I'm so proud of all of you. I miss all of you a lot. I miss teaching. Just keep going, keep powering through. Email me if you have questions, okay? I want to help. Have a great day.